We next take a look at the random proportionality problems on version 1 for today's assignment. Now these problems have solutions. You can look at the solutions, but I'm going to go through most of the first 8 problems and talk about the nature of these solutions. The first problem says we have 2 cubes. One has a uniform side of 7, the other uniform side of 8. And we want to know by what factor we multiply the volume of this cube to get this cube. Now that factor, it turns out, is going to be the ratio of the volume of this cube to the volume of this cube. We could easily find that ratio by finding the 2 volumes, because of course we can find the volumes of the cubes easily if we know the sides. And the ratio is going to be 512 over 343. However, sometimes the dimension that we're given of an object doesn't allow us to easily find the 2 volumes, so we can find the ratio of the volumes. And that's what we want to look at now. So what we do know is that the volume of a cube is proportional to the cube of its linear dimension. And we're going to let x in this case stand for the length of a side. So even if these weren't cubes, if they were spheres and these were diameters, or if they were pyramids and these were altitudes, as long as the pyramids were similar, or cones of similar shape, where x could be the altitude or the diameter of the cone. This would apply in any of those cases, so the thing that we're going to do here doesn't apply just to cubes. What we're going to say is that if V1 is the volume corresponding to a side of x1, and V2 is the volume corresponding to a side of x2, then V1 is kx1 cubed and V2 is k times x2 cubed, obviously. And then the ratio of volumes is going to be volume ratio V2 over V1 is kx2 cubed over kx1 cubed. The k's divide out and give us 1, so we end up with x2 cubed over x1 cubed. And of course that's the same as the quantity x2 over x1 cubed, so that the volume ratio is just the cube of the ratio of the sides. Again, this argument would be identical if x stood for the radius or diameter of a sphere, for the altitude of similar pyramids or similar cones, for the diameter of the base of similar cones, etc. The volume ratio is the cube of the ratio of the linear dimension. And we'll also just mention that V2 over V1 is the factor by which the volume increases as we go from V1 to V2. Well, in this case, with the cubes having sides 8 and 7, then V2 over V1 is going to be 8/7 cubed, which of course is 8 cubed over 7 cubed, 512 over 343, approximately 1.5. So that a small increase in the side from 7 to 8, that's only about a 14% increase in the length of a side, gives us 1.5 times the volume, or a 50% increase in volume. It's an important idea and an important concept.